Today's LeetCode problem is about post-order traversal binary tree. The link of the problem is provided in the description below. As usual, I recommend go and try the problem yourself. So let's start. There is a value, left and right are provided. Here is root. Let's see the root value. It's 1. We can see here the structure of the binary tree. As we see here, the root is 1. What about root right? It is 2. And root right left, it is 3. As for the root right, nope, it throws an attribute error saying that object has not value. That's right, because there is not object on the root right. We can see the same structure here on the LeetCode description page also. Here is the input here, and here is the expected result. Okay. Now let's write down an algorithm which returns the expected result. To do so, we can create a recursive function that performs the post-order traversal and appends the value of the nodes to the list. Inside this function, first visit all nodes on the left subarray, then visit all nodes on the right subarray. After that, we can visit the node and append the value to a list. And we may name this list pre-ordered list. Let's create this list above here outside of this helper function. Also, after traversing the left and right subtrees, the value of the current node root is appended to the post-order list. This ensures that the current node's value is added lost in the post-order traversal. It will be more clear if I show you this with this way. So visit left subtree and append its value to the post-order list, and we do the same for the right subtree. The entire process repeats for each subtree until all nodes in the binary tree are visited, resulting in a post-order traversal. Then we take care of this root value. We will append this root value to the post-order list soon. But first, let's take these recursive steps of the algorithm inside this helper function. First argument is self, including self as the first parameter of the method. Self post order. It allows the method to access and modify the attributes of the class instance. The next argument is this root, but we better change it root underscore, and then we need this post order list to store the value of nodes in post order. Okay, now let's clean the code and let's avoid the infinite recursion, because there is a question: what if the nodes are none? So we must be ensured that the recursion stops when it reaches leaves of the tree, nodes with no children, or when it encounters a non-value, preventing infinite recursion. And finally, we start the post-order traversal from the root of the binary tree. It triggers the recursion post-order traversal of the binary tree, and the result is post-order traversal stored in post-order list. After initiating the post-order traversal, we may return the post-order list as the result. Oopsie, I forgot to call the helper function, helper method, and left this part of the algorithm as the concept code. Yeah. Okay, let's call the helper function post-order recursively, and then we can append this root value to the post-order list, like this. As we see, it returned the expected result, 3, 2, 1. And we can see this expected outcome here on the LeetCode problem description. Hey world, we solved the problem. Congratulations.